Folks, today's really our last day on formula writing. Now we're going to learn, as we move ahead, we're going to learn how to actually use the formulas to do important chemistry. But go ahead and open your Chromebooks. We'll take a look at the homework that was due. When was it due? We'll take a look at the homework here. So this is really one of the last times we will deal with this. We have one more assignment that we'll go over. It probably was posted this morning sometime, 6D10. So 6D10 will be our check to make sure you understand what you're doing. So to help you with 6D10, be sure to ask questions on 6D9. We're going over that right now. Question on number 1. If you have trouble on any of these, ask. Today is set aside to help you understand this stuff. How about number 2? Question on 2. Does this answer key help at all? Maybe, I don't know. What about number 3? How are we doing on 3? Might have done, did we do number 4 in class? But let's take a look at it again, because there's one on tonight's assignment or today's assignment just like this. Question on number 4. This is a little trickier than the other ones. How do we feel about this? Five? Six? Yes.
Can you go over and find 6?
Number 6. They would like us to write the formula for thiocyanic acid. We have to remember that the acid form simply has the hydrogens still on the polyatomic ion. How do I know, first of all, that there's going to be a polyatomic ion in this acid? What doesn't it begin with? A little trick that works almost every time. If the name begins with hydro, you know it's what? It's just binary. If there is no hydro in front, and this works almost every time. If the word hydro is not in front of it, it is a ternary acid, meaning that it's a poly. So this one's going to have a polyatomic ion on it. So thiocyanic acid. I have to remember that ic acids produce the 8 ions when the hydrogens come off. Ic acids. I ate it and it made me sick. Sick, this is the acid form. Ic is the acid form. 8 would be the form of it when the hydrogens have come off and the polyatomic ion is left. So I would be looking for the thiocyanate ion. If you look on your polyatomic ion sheet, can you find the thiocyanate ion? Does anybody want me to show you where it is? I'd be happy to do that. So I look at the thiocyanate ion, and it is SCN minus. That minus means that this is the form where the hydrogen is off. If it's 1 minus, how many hydrogens were on it at one time in the acid form? 1. 1 H plus broke off and left the hydrogen behind. So the acid form is HSCN, thiocyanic acid, or thiocyanic acid, thio or thiocyanic acid. Question on that. Does that make it better sense?
Yeah.
Get a chance to practice these a little bit more. This is an essential skill. This is like chemistry essential stuff. Being able to write formulas. The next unit we're coming into, actually the next videos we'll watch, we'll begin using. We will begin using. Hello, there you are. These formulas. How about number 7? 7. Take a look at it. See if you understand it. Did we do number 7 in class as an example? What about number 8? You guys are very comfortable with this stuff? Number 9. How about this answer key? Are you guys loving the answer key here? Did you look at it? Oh, number 10. Whoa. Number 10. One of the most missed ones. Question on 10. A lot of people put letter A. Why is it letter B and not letter A? Fluorine's never found by itself. Do you remember Brinkelhoff? The diatomic elements, do you remember that? That was back in August 14th when we first saw that. It all comes back again. The beauty of the subject of chemistry. Question on number 10? Yes. They want us to write the formula for fluorine, not the symbol for fluorine. The symbol for fluorine is F, but you never have fluorine by itself. It always join up with another fluorine. Why? Why will fluorine always join up with another fluorine? Here's a fluorine. If we draw the atom fluorine, it would look something like this. There's fluorine, 7 valence electrons. What happens? That fluorine needs a what? Another electron. So if another fluorine gets near it, what will they do? I'll try to draw these electrons in a different color. 1, 2, 3, 4, 5, 6, 7. What do the fluorines do? Join up immediately. Why? They form a single bond between them to satisfy the what? The octet rule. Every time. You can't get a fluorine by itself. So they're always found. What's the formula for this? That's F2. They're always found in 2s. Brinkelhoff is the easy way to remember which ones are always found in 2s. BrIN2Cl2H2O2F2. Did we do number 11 in class? We're happy to talk about it again. Number 11. Happy to talk about it again. Why? I wait all weekend to talk about these things. Number 11. What about 12? Why does my mouse thing keep disappearing on this thing? Where is it? Where have you gone? Let's try it over here. Where are you? What is going on with this thing? Am I the only teacher that has trouble with this? Where are you? $12? $13's a tough one. What did you have to do on 13? This is one, sort of like water. Water's not called dihydrogen monoxide, H2O. It's called water. Ammonia is seldom called nitrogen trihydride. It is just NH3. That is the common name. It goes by the common name more than it goes by its actual chemistry name. Ammonia is one you're just going to have to know is NH3. Chem 1 students should know that. $14. Take a good look if there's any of these that you're having trouble with. 14. Yes, absolutely. They want to know. And this is everything kind of all shown for you here, but let's just start from scratch. Step 1, we write the formulas or symbols that go with this. So they want ammonium. Ammonium, you would have to look on your polyatomic ion sheet. It's at the top of the polyatomic ion sheet. Ammonium is NH4. What is its charge? 1 plus. So I'm going to write the charge right above it, 1 plus. And it's with sulfide. I've got sulf and it ends in ide. So I know that that is the element sulfur that has now gained its 2 electrons. Sulfide has gained its 2 electrons. If you look on the periodic table of ions, you'll see in sulfide square S2 minus. So I have sulfide at 2 minus. I have ammonium at 1 plus. This is ionic. I have 2 differently charged. I have an anion and a cation. Opposite charges. Positives and negatives together. That is an ionic substance. So first, write the formulas. Second, write their charges. Third thing we're going to do is analyze those charges. Can a 1 and a 2 be reduced? No, you cannot reduce those. That's already the simplest whole numbers we have. So then we use the crisscross method to get the, I guess you could call it the lowest common multiple, least common multiple right there, yes? So we're going to crisscross the charges. I'm bringing a 2 down to the ammonium ion. Anytime you bring a number other than 1 down to a polyatomic ion, we use brackets to offset the number we brought down. Now I'm bringing a 1 down to the sulfide ion. It's understood to be there. We don't have to write it. If we did write a 1, it would be here. That 1 would come right down there. That one would come right down there, but we don't write a 1. It's understood to be there. Now I check my total charges. How many sulfides do I have? 1. The total charge, 1 times 2 minus is 2 minus. I have 2 ammonium ions at 1 plus. 2 times 1 plus is 2 plus. My charges are balanced. That's my check. The total charges are right there. That's my check. How does that help? It's okay? Never hesitate to say, if I did not explain it well enough, to try again. What about number 15? Oh, perfect. What about number 15? $16. Whoa, what about 17? 17, I always like to ask. This is an ionic substance, sodium oxalate. It has the positive sodium with the negative or 2 negative oxalate ion. I thought then we represent ionic substances with empirical formulas. Empirical formulas mean to do what? Reduce them. Can I reduce the 2, 2, and 4? No. You're like, but those 2, 2, and 4 can be reduced. You reduce the numbers before you bring them down, not after. This 2 and the 4 go with who? The 2 and the 4 go with the formula for the oxalate ion. If I reduce this to N NaCO2. That would be reduced, yes? This is not the oxalate ion. That's carbon dioxide. You can't reduce the subscripts that are part of the polyatomic ion that you're representing. Question on that one. Why don't I put parentheses around the C2O4? I'm bringing a number down to it. Why don't I put parentheses around it? Yes. Yeah, you don't have more than one of those. You only use parentheses when you have more than one of those. What about 18? Question on 18. $19. Take a look at what you have. Now's the chance, because we're going to be doing more of these for our final assessment on this in just a few moments. So now's the time to ask. If you understand how to do these, the homework becomes very easy. The assignment becomes very easy. What about number 20? Fantastic questions, please. 21. Oh, yeah. Absolutely. This is writing the formula for an acid again. And ic acids are related to 8 ions. I ate it. It made me sick. What's the other polyatomic ion ending? Not us, or not 8, but ite. Ites are related to what? What? Us or ouse, yes? Lighthouse. So, to get the formula for pyrophosphoric acid, we need to know what the pyrophosphate ion is. It happens to be P2O7. That one is not on your polyatomic ion sheet. You're like, well, where did you get it? Well, it wasn't on the polyatomic ion sheet, so we gave it to you directly on the assignment. That one wasn't on there. I was just trying to show you with this one that not every polyatomic ion in the world is on your polyatomic ion sheet. Not even close. The formula is P2O7 and its charge is 4-. So in the ion form, where did the ion form come from? Well, at one time, there were how many hydrogens on here? There must have been the possibility of having 4. So to write the formula for these ternary, and in this case, oxyacids, in order to write the formula for a ternary oxyacid, you need to know what the polyatomic ion is and what its charge was. Whatever its charge was is how many hydrogens at one time could have been on that thing. Would you like to talk about that one more, or is that? Next one's very similar. Question on the next one. How about 23? Yes.
Can you go over that one?
Aluminum borate. Well, I have a metal here, so it's probably going to be ionic. The borate is a polyatomic ion. No surprise, it has the element boron in it. The borate ion is BO3 3-, so we write that. Aluminum is Al, we write that. I have to know that the borate ion is 3-, so I write its charge above it. I look on the periodic table, aluminum is in Roman 3, so it is 3+. So step 1, write the formulas or symbols. Step 2, write their charges above them, the individual charges. Step 3, analyze the charges. Can a 3 and a 3 be reduced? Yes, we want the lowest numbers. I reduced the 3 to a 1. 3 is reduced to a 1. Now I'm ready to crisscross. That 1 comes down here. That one goes down there. It becomes AlBO3. Check my total charges. How many borate ions do I have here? A lot of people want to say 3. Why? Because they see the 3 there. No, the borate ion has 3 oxygens on it. How many borate ions are there? 1. If there was more than 1, we would see parentheses. So there's 1 borate ion charged at 3-. You're like, no, I reduced it to a 1. You didn't reduce the charges. Did you notice that? I didn't get rid of the charges. I reduced the numbers in the charge. When you reduce, you're not saying the borate ion is 1-, aluminum's 1+. You're reducing the numbers, not the charge. So to figure the total charge, to see if we've done this right, it's 1 borate at 3-. How many aluminums do I have here? 1 at 3+. Good question. Did that help? If it didn't, you can make me continue teaching about it by just saying, I still don't understand what you're doing. Manganese 3 permanganate. Yes. Absolutely. First, we're going to write the symbols. The symbol for manganese is Mn. I have to look up the permanganate ion on a polyatomic ion sheet. We would see that it is MnO4. On the polyatomic ion sheet, we would say the permanganate ion's charge is 1-. It's on the polyatomic ion sheet. What is manganese's charge? It's a transition metal. Many of the transition metals and the post-transition metals, the ones that come after the transition metals in the P block, can have multiple charges. How am I supposed to know what manganese's charge is? It tells you right there in the formula. It is 3+. It is 3+. So now I've got their charges above them. Now I look, can I reduce the charges? Can a 3 and a 1 be reduced? No. I'm ready to crisscross. This 3 goes down to the permanganate ion. This one goes to manganese. I'm bringing a number other than 1 down to a polyatomic ion. So what do I need to do? Separate it with parentheses. Anytime you're bringing a number other than 1 down to a polyatomic ion, use parentheses. That's kind of a weird formula. Look at that. Manganese permanganate. This Mn is in a molecule with the oxygens charged at -1. This is just the manganese ion. That's a very weird one. How about this one? Oh, wait, did 24 clear enough, or do you want it more? What about 25? 25. Yes. Let's do 25. First, we're going to write the names and symbols. So manganese, I look on the periodic table, it is Mn. Oxide is oxygen. You're like, how do I know that? Well, it has the "ide" at the end with an element. Element followed by "ide" is, in fact, in this case, the anion of oxygen. So I would write Mn. NO. I know oxygen is in family Roman 6, so it needs 2 electrons in order to satisfy the octet rule. If I forget that, I can look on the periodic table of ions, look in oxygen square, and you'll see oxide. It says in oxygen square, oxide, 2-. So if you ever get confused on the charges of those, look them up. How am I supposed to get manganese's charge again? It'll tell us right there in Roman numerals, since it has more than 1 charge. That is Roman 7. Can I reduce a 2 and a 7? No. I analyze the charges, then I'm going to crisscross the charges to get the least common multiple. The number that 2 and 7 go into. The 2 comes down to here. The 7 goes over to the oxygen. Why? 7 times 2- is 14-. 2 times 7 plus is 14 plus, my charges are indeed balanced. Any questions in general? Yes.
So on the periodic table of ions for manganese, it says that there's multiple charges for it, but it doesn't have like.
What it does on that periodic table of ions is it gives you the more common forms of it. Like if I remember, manganese, I think can be like 2 plus, 3 plus, 4 plus, 6 plus, 7 plus, or something like that. Something like that. It has more than things. On that chart, I think it just gives you the more common ones. They just fit them all in a little square. It would mess the whole thing up. So when in doubt, if they give you a Roman numeral, just use it. If they give you a Roman numeral, use it. Now, if they ask you whether the Roman numeral is possible or not, like, is it possible for manganese to be Roman 7? The answer is, if it's not on the periodic table of ions, it could be possible. You don't have the information to answer that. So just use the ones that they give you. Good question there. Anything else? Folks, we're down to our final practice on formula writing. I think 6D is at 10. Yes, I will post the answer key to that later today. The answer key is ready to post, but I don't want to put it straight up. I want you to have the opportunity to do your best and come to an answer so that you don't have the enjoyment spoiled for you for writing the formulas by like, oh my gosh, I'm not sure. Take a chance, figure it out, see what you can do. These will be due tomorrow. And then we will progress into using formulas tomorrow. Again, the answer key, I might wait till like 2 o'clock or something to post it. It'll be hard for me to wait. I will wait. As always, if you have any questions, let me know. And good luck.